Hello, my name is Walmir, and I'll be covering the different modes on the TestScan Vega 3 scanning electron microscope. Once after the software is launched and you have your vacuum pumps and your HV up and running, you will want to look for the icon that's called mode that's located right here on the top right. After moving your mouse cursor to the icon, a list of different modes would appear, and then select which mode you want to choose. For this case, we're going to choose the resolution mode as our first choice. And what is the resolution mode? It is basically the most common display mode. What happens is that the intermediate lens is switched off while the objective lens is excited, and it focuses on the final electron beam. The purpose of this mode is for a high resolution image with a lower depth of focus. In this mode, the microscope focuses with objective lens only. The aperture is nearly optimal for lower beam intensity values with a small spot size with a low beam current, short working distance which is about 4 to 5 millimeters, and an accelerating voltage of 30 kV. The pivot point of the scanning and the electron image shifts are close to the principal plane of the objective so that the field of view will be as good as possible. The centering of the objective is performed by a defined beam tilt of the central electron beam, which does not cause the image shift. This mode is intended for displaying with the highest resolution. Next on the list would be the depth mode. Depth mode differs from resolution mode by the usage of the intermediate lens. The aperture of the final beam is lower, but the spot size is bigger in comparison with the mode of resolution. The beam and the probe stays unchanged. This is recommended for basic imaging at moderate currents with increase of depth of focus. It's mainly good for good resolution, but with an increase of depth of focus. Next on the list would be field mode. Field mode utilizes the intermediate lens for electron beam focusing while the objective lens is off. The beam aperture is very small and the depth of focus is usually higher than the field of view. As the objective is off in this case, it does not affect the middle beam and thus does not need to pass near the center of the objective. The position of the pivot point of scanning is optimized according to the field of view. The centering coil's intermediate lens center the supplementary intermediate lens to avoid image movement during focusing. The scanning coil is set up so that no image shift occurs if switched from the mode resolution to the field mode. The disadvantage of this is bigger spot size. The maximum magnification is a few thousands. The mode is used as a navigation on the specimen. Its main purpose is for a large field of view, high depth of focus, but low resolution. Next on the list would be wide field mode. Wide field mode uses the intermediate lens for focusing electron beam while the objective lens is excited at a high value. Highly excited objective multiplies the deflection of the beam. The aperture of the beam is very small and the depth of focus is very high. The intermediate lens centering coil serves for minimizing the image shift when focusing. The mode is used for searching for parts of the specimen for analysis or investigation. To know the proper magnification value, the objective must be well focused. This might be a bit difficult due to the high depth of focus. The purpose of this mode is for extra large field of view. Image distortion is corrected and minimized. Last but not least is channeling mode. In channeling mode, the scanning and the lens focusing is controlled so that the electron beam impinges onto one point of the specimen surface all the time. By means the scanning of the beam, only the angle incidence of the beam is changed. The resulting image is the amount of electrons dependent on impacting. The resulting image is the amount of electrons dependent on the impacting beam angle. The excitation ratio of the scanning coils is set up so that the beam utilizes the whole area of the ejector lens bore and enters the lens parallel to the optical axis. All electron beam parallel to the object axis are focused by the lens into a single point on the specimen surface. As a consequence, the scanning is transformed into a beam tilting. An example: the resulting pivot point of the scanning lies on the specimen surface plane. The intermediate lens focuses the beam into the upper focal point of the objective lens. The result is that the beam, after it passes through the objective lens, is parallel, and angular resolution of electron channeling pattern images is at its maximum. The minimum size of the crystal should be 100 to 150 micrometers. The purpose of this mode is to position the specified point in the image that is depending on the beam tilt.